All right, everyone. Hello, and welcome to the second screencast for the elasticity chapter, chapter 4. In this screencast, we're going to simply be learning how to compute the on-price elasticity of demand. It's a relatively short screencast. We're just going to go through a couple formulas, but it may be one that you need to watch a couple of times to kind of get the swing of what it is that we are doing in this screencast. But that's one of the nice things about having these is you can watch them over and over, all right? So how do we compute the on-price elasticity of demand, all right? Well, elasticity can help us answer certain questions, such as, should a firm raise or lower the price of a good to increase revenue? So why would a firm, though, want to lower prices to get more revenue? Well, if their price of their good is so high that some people are not buying it at all, it could be the case that if they lowered their price, they would sell more and therefore get more profit. All right. So we'll do producer stuff later on in the semester, but so the revenue that a firm gets is just the price of the good times the quantity that they sell. That's the revenue. For now, we'll just call it P times Q equals R, right? Well, if Q is so low that they're not selling very many, if P is so high that they're not selling very many, Q will be low and R will be low. So maybe by lowering P, they get a higher Q because that's the law of demand, right? If price falls, quantity demanded increases, it could be the case that they could increase their revenue. And as it turns out, whether or not increasing or decreasing price earns you more money will depend upon the elasticity that's going on. So that's why one of the reasons that it's such an important concept, all right? Another is, will an excise tax, which just means a tax per unit on a good, if the government places a tax on a good, how much tax revenue will be generated? If you tax a good, raising its price, and it causes people not to buy the good at all, then you're not going to raise very much revenue. If you tax a good and people don't change their demand much at all, meaning they're inelastic, then you're going to raise a ton of revenue. All right. So understanding whether or not a good has elastic demand or inelastic demand can be important for both firms, and it can be important for government. All right. So here is the formula for the on-price elasticity of demand. All right. So this just means the elasticity of demand. And this is the percent change in the quantity demanded. How much did quantity demand change when you changed the price? And this is the percent change in the price, right? So if you increase the price 4% and quantity demand falls 6%, you plug those in and you find what the elasticity of demand is, all right? Again, the book doesn't, the delta here, just to remind you, means change. So this means percent change in the quantity demanded, all right? Remember, this quantity and this price are for the same good. The price of eggs goes up, the quantity demanded of eggs goes down, plug in those percent changes, and you get the on-price elasticity of demand. Later on, we're going to look at cases where this isn't the same good, and that's going to be something different. So again, that's why I have, throughout this chapter, inserted the word own here. Own price elasticity of demand, all right? Because this is for the same good, all right? So let's do a quick example here, all right? So the university parking pass prices increase by 50%, all right? As a result, 25% less people demand a parking pass. So prices go up by 50%, the quantity demanded falls by 25%. Let's use that and plug it into our formula here, all right? So let's plug that in. So here, what is the percent change in the quantity demanded? Well, the percent change in the quantity demanded is 25% less, or negative 25%, all right? And the percent change in price is 50% increase, all right? It's important to put the negative sign on the side that's decreasing and put the positive sign on the one that's increasing. So we get negative 0.05. So that is the elasticity, on-price elasticity of demand for this particular university's parking passes. All right. So what does that number mean? What does negative 0.5 mean? Well, in this case, the quantity demanded was relatively small considering how big the price change was. We increased the price by 50%, and the quantity demanded only fell by 25%. So the magnitudes of these changes, big change, percent change in the price, we get only half as big a change in terms of the quantity demanded. So this is an inelastic sort of result. Think through it this way. Most people don't have other options when it comes to parking on campus. So if the university doubles the prices of parking, yes, it will fall. Quantity demanded will fall, but a lot of people will just have to suck it up and pay the increase. All right. So it is an inelastically demanded good. All right. Well, why is it negative though? Well, notice, because of the law of demand, if I increase price, the quantity demanded will fall. So if this is positive, this must be negative. All right. Also, according to the law of demand, if I decrease price, then the quantity demanded should go up. So either the numerator or the denominator will always be negative. The other one will not be negative, and so that means you'll get this negative value for the slope. All right. So now that we've learned this percent change formula, unfortunately there's an issue with the percent change formula. Some of you may already know, anytime you talk about percent changes, there's always a problem of comparing one percent change to another. And here's basically what the problem is. So let's say price decreases from 100 to 80. Well, that's a 20% change, right? $100 to $80 is a 20% change. Well, what if price increases from 80 to 100? That's actually a 25% increase. All right. So, as it turns out, the percent change formula is very influenced by the direction that the variable changes. That's no good for us, because then we're always going to have to be talking about, well, do you mean a percent increase from this to this, a percent decrease from that to that? Notice we would get different elasticities depending on which direction we go. That's all no good for us. So we're going to fix that by most of the time using a different formula. And we're going to use a midpoint formula. All right. So what do we mean by midpoint first? Well, notice we're going to have an original quantity demanded, and then we're going to have a second quantity demanded. So QD prime. We're going to have an original price, all right? And then we're going to have a new price once we change the price. So let's say the price is $100 and we increase it to $150. Well, quantity demanded was maybe 50 and it fell to 25. So you're always going to have two different prices, the original price and the new price, the original quantity demanded and the new quantity demanded. So the midpoint says, well, let's find the middle distance between these two numbers and the middle distance between these two numbers and use that to find our elasticity, all right? Because the midpoint between these two is not subject to which one is the end point, okay? It's not subject to whether or not we're going from this price to this price or this price to this price, okay? So that percent change problem goes away. So here's what it looks like. And it's kind of ugly and gross looking, but you'll see that it's actually not too tricky when you break it down. So we're going to find the change in the quantity demanded divided by the average of the two quantities. Average of what two quantities? Well, remember, we had a Q, and then the Q went to the Q prime, all right? So the difference between these two goes here, all right? That's the difference. And the average of the two goes here. So you add them together and divide by 2 goes here. And the same thing is true of the price, right? You had an original price, and then you had a new price when you changed the price. So this is the difference between these two, and this is the average. So you add them up and divide by 2, all right? So when you write that out as a formula, you get the original quantity plus the second quantity divided by 2. Here you get the second quantity minus the first quantity. All right, this is just the difference, the distance between the two, and this is just the average of the two. Again, and the same thing here in the denominator. All right, so this is going to be our formula for the elasticity of demand. So quantity 2 minus quantity 1 divided by the average of quantity 2 and quantity 1. P2 minus P1 divided by the average of P1 and P2. P1 plus P2 divided by 2. All right, so you just kind of have to break it down into its parts and then make sure you can put it all back together. All right. So yeah, so this is just going to link those like I showed you there. This is the change in quantity demanded. That's the average. This is the change in the price. This is the average of the price. All right. So this alternative gives you a way to find the elasticity, and it doesn't matter which way you start. As long as you keep the second quantity, the second quantity, the second price, you'll always, as long as you keep that straight, you'll always get the right answer. Okay, so let's look at an example here. All right, so here we have a price of $6. At $6, the quantity demanded is 15. We're going to decrease the price to $4. At $4, the quantity demanded is 25. So we had a price decrease. We had an increase in the quantity demanded. That confirms with our law of demand. All right. So now let's take these numbers and plug them into our midpoint formula. All right. So for Q2, that's 25. For Q1, that's 15. All right. For Q1, that's 15. For Q2, that's 25. Again, this is the average of the two. This is the difference between the two. Down here, P2 is $4. P1 is $6. $6 plus $4, which is P1 plus P2, divided by 2. Again, this is the average. So let's see what we get here. So 25 minus 15 is 10. Divided by 15 plus 25 is 40. Divided by 2 is 20. Okay. So this is 4 minus 6, which is negative 2. Divided by, here we have 6 plus 4 is 10. Divided by 2 is 5. So we have 10/20ths divided by negative 2/5. I'm going to put that here. So 10/20ths is the same as 1/2. And that is divided by negative 2/5. So if you remember your rules from algebra, I can take this 2/5 and flip it up into the numerator. And so I will get 1/2 times 5 over negative 2. All right. And so what I get is 1 times 5 is 5. Negative 2 times negative 2 is negative 4. And that should be my answer, negative 5/4. And let's see what the slide tells me. And good, I got it right. So 10 over 20 over negative 2/5 is negative 1.25. I prefer to stay in the world of fractions because fractions are your friend. All right. So the last thing I want to leave you with here is a clip. And it's a clip from Seinfeld where we see that George and Jerry likely have different own price elasticity of demands for the jacket. The name of this episode is The Jacket, and the clip you're going to see, they're going to be discussing the price of it. And it's pretty clear that they have very different elasticity of demand for the jacket.